Hilbert systems are elegant but hard to use. Natural deduction is closer to ordinary mathematical reasoning. It has rules rather than long lists of axioms. The most important idea is temporary assumption. You may assume something, derive a consequence, and then discharge the assumption to prove an implication or a negation. The rules match how we naturally reason. To prove A and B, prove A and prove B separately. If you already have A and B, you may extract either part. To prove A or B, prove one side. To use A or B, reason by cases. To prove A implies B, assume A and derive B. To prove not A, assume A and derive contradiction. Once a contradiction has been derived, different logics make different choices. In intuitionistic logic, a contradiction can imply any formula. In classical logic, we also allow proof by contradiction to prove A, assume not A, derive contradiction, and conclude A. Classical logic validates excluded middle A or not A, while intuitionistic logic is more cautious about such principles. Jensen's sequent calculus writes judgments as gamma entails delta. The left side gamma is a collection of assumptions, and the right side delta is a collection of possible conclusions. The meaning is if all formulas on the left are true, then at least one formula on the right is true. This notation makes assumptions and conclusions appear in a very symmetric way. Sequent calculus includes structural rules. Weakening lets us add assumptions or conclusions. Contraction lets us merge duplicates. Exchange lets us reorder formulas. Cut lets us prove a lemma and then use it. Jensen's famous cut elimination theorem says that anything provable with cut is also provable without cut. This is crucial for proof search because it means we do not need to invent arbitrary lemmas.